are in the series of electronic physics, and today's topic is the diodes. We are discussing the different types of diodes here. There are number of diodes whose construction is similar, but the type of material we use are differ. So, there on the basis of the material we are using, we can have the different type of diodes. So, for example, if we consider a light emitting diode that is made of the aluminium, gallium and arsenide materials, which when excited releases energy in the form of the light. Similarly, variation in the diode properties like internal capacitance, threshold voltage, etc. are considered, and a particular diode is designed based on those. So, now what are the types of diode? Here we are having many types of diode. First is the Zener diode, which is most commonly used diode in the electronic circuit. Second is the LED diode, that is a LED diode. LASCR laser diode, that use the laser light. Photodiode, Varactor Diode, Schottky Diodes, tunnel diode, pin diode, etc. They are the different type of diodes, and we will discuss one by one. These are the various symbols of the diode. As you see, there are the various diode and they are represented by these symbols. So you can see some of symbols are here, like the junction diode is a simple diode representation. Zener diode, you see the second one. Tunnel diode, there is a loop in it. Schottky diode, and you can see on the last, you can see light emitting diode, where the arrow is also put on it, and last is the photodiode, where the light fall upon it. So light emitting diode and the photodiode, both are the different diodes. So these are the various diode symbols which is made of the semiconductor. Now we discuss the Zener diode first. What is a Zener diode and how it is used, and what is its construction, how its characteristics. Now diodes generally are made of the devices that allows the flow of current in a one direction, forward biases, and offer the resistance to the flow of current when uses in the reverse biases. So it works in the reverse bias. So Zener diode, named after the American scientist Zener, who first explained the operational principle of the Zener diode. On the other hand, not only allow the flow of the current when used in the forward bias, but they also allow the flow of current when used in the reversed biased also. Not only in the forward bias they allow the current, but also in the reversed bias. So far the applied voltage is above the breakdown voltage, and it works in the reverse bias also, and that if it works in the breakdown, then above the breakdown voltage, then it is known as the Zener breakdown voltage. The other words, breakdown voltage is the voltage on which the Zener diode starts conducting in the reverse direction. At the breakdown voltage, Zener diode conduct in the reverse direction, and it works. Now here you see the symbol of the Zener diode. Now, operation and the principle of the Zener diode. In the normal diode, the breakdown voltage is very high. In the normal diode, we are having the very high voltage breakdown, but diodes get damaged totally if the voltage above the breakdown voltage is applied. But in case of the Zener diodes, the voltage must be above the breakdown voltage, and it does not lead the permanent damage of the Zener diode. The voltage is applied in it. Now, as the reverse voltage applied to the Zener diode increases towards the specified breakdown voltage, that is represented by the Vz. A current starts flowing through the diode, and this current is known as the Zener current. As the voltage applied above the breakdown voltage, the current flows, that current is the Zener current, and this process is called as the avalanche breakdown. When the voltage applied above the breakdown voltage, current flows in the diode, that is a Zener current, and that process is called the avalanche breakdown. Now the current increases to the maximum and get stabilized. Current remains constant over the wide range of the applied voltage and allows the Zener diode to withstand with the high voltage without getting damage, and it works in the reverse conditions. That's why this current is determined by the series resistors. Here we consider the images below of the normal diode in the action. You see the two diodes are attached here. Now to show the operation of the Zener diode, consider the two terminal. Here we are having the two example. Number one example is the first experiment consider, that is the A experiment, where the 12 volt Zener diode is connected in the reverse biased as shown in the image. You can see on the diagram that a 12 volt Zener diode is attached with the terminals, and it can be seen that the Zener diode blocked the voltage efficiently because it was less or equal to the breakdown voltage and voltage of the particular Zener diode, and the lamp thus stayed off. Now in the experiment B, if the 6 volt Zener diode is applied, conducting the bulb comes on in the reverse biased because the applied voltage is greater than that of the breakdown voltage, and thus it shows that the breakdown region is a region of the operation of the Zener diode. That's why it is works in the breakdown voltage. If the breakdown voltage is above that then it will work. Now this is the diagram. This is the characteristics of the Zener diode, or you can say it is a current voltage characteristics of the Zener diode. Zener diodes operated in the reverse biased mode and will have a fairly constant voltage irrespective of the amount of current applied. Now you see in the reverse volt in the left hand side, you will see that it is working in the reverse biasing Zener breakdown region where it is working, and it stay for a longer time here. Now application of the Zener diode. Zener diodes are used in three main applications in the electronic circuit. First is a voltage regulation, second is the waveform clipper, and third is the voltage shifter. So these are the applications of the Zener diode that we will discuss later. Now next diode is the light emitting diode, and its construction is similar to the simple diode, but various combinations of the semiconductor materials are used to generate the different colors of the diodes, and it works in the forward biased. Many different semiconductors which are having the different colors, when the voltage applied, then they are used in the construction of the light emitting diode. Now when the electrons hole recombine takes place, as a resultant photon is released which emits light. In this case, when the electron is recombined in the depletion layer, the photon takes place, a resultant photon is released which emits the light. If the forward voltage is further increases, more photons will be released, and the light intensity also increases in this light emitting diode, but the voltage should not exceed at its threshold value, otherwise that LED diode will damage. So up to the threshold value the voltage will increase, and the number of photons increase, and the light intensity which is released also increased. So to generate the different colors, combinations are used, like aluminum gallium arsenide, like red and infrared color that will produce by the aluminum gallium arsenide. If we use the gallium phosphide, then the yellow and green color we can use indium gallium nitride, then blue and ultraviolet LEDs we can get. So now here this is a symbol of the LED diode, and here are the different colors of diodes we can have on the basis of the material which we are using, like gallium, like aluminum gallium arsenide, that will produce the red and infrared, yellow, green and blue and ultraviolet type of diode we can get. Next is the laser diode. Laser diode is one of the basic diode which are commonly used nowadays. Laser stands for the light amplification by stimulated emission of radiation, and it is a PN junction is formed by the two layer of the doped gallium arsenide, where a high reflective coating is applied to one end of the junction and the partial reflective coating at the other end. As in the laser we also do it, that the output will get from the one partial reflected side, and the main is a high having the one is fully coated, where we can get the avalanche of the electrons or holes. So when the diode is forward biased, similar work done is by the LED, and it releases the photon, and this hit the other atoms such that the photons will be released excessively, means amplification of the photon takes place here in the laser diode. This is the one type of laser diode. When the photon hits the reflective coating and strikes back in the junction again, and more photons released, and this process repeated up to the high intensity beam of the light released is only one direction. So this is the one type of laser diode. Now next is the photodiode. In the photodiode, the current through it depends upon the light energy applied on the PN junction diode. The LED diode release the photon and produce the light energy, and similarly the laser will also produce the light energy. But here in the photodiode, the current through depends upon the light energy applied to the PN junction. Here the light energy is applied. If it is operated in the reverse biased, then we can have the breakdown voltage. So as discussed earlier, small leakage current flows through a diode when reversed biased, which is here, it is called the dark current. As it is working in the reverse biasing, so it is called the current which is flows is called the dark current. In the photodiode, as the current is due to the lack of the light darkness, it is called so. It is because here we are using the less light. This diode is constructed in such a way that when the light strike the junction, it is enough to break the electron hole pairs and generate the electrons, which increases the reverse leakage current. So by using the photodiode, we can get the reverse leakage current. That's why it is work in the reverse biasing. This is the one type of diode which are left hand side. This is the symbol of the diode. You see the arrow is inside the diode, and in the LED you see how it is different. This is a photodiode. If you see in the LED, the arrows are outside because light is emitting here, and here we are using the light fall upon a photodiode. So this is the right hand side. This is the original diode which we use. Vector diode, and it is also called a varicap variable capacitor diode. It operates in the reverse biasing mode. So like the photodiode, it is also working in a reverse biasing mode. The general definition of the capacitor: separation of the conducting plates with an insulator or a dielectric. When a normal diode is reverse biased, the width of the depletion region increases. As we know that in the reverse biasing, the width of depletion region, as the depletion region represent the insulator, as a dielectric can now act as a capacitor. Now when the variation of the reverse voltage causes the separation of PN region to vary, these lead the diode to work in the variable capacitor. It is worked as a variable capacitor. Since capacitance increases with the decrease in the distance between the plates, the larger the reverse voltage means the low capacitance, or vice versa. Next is the Schottky diode, where the N-type semiconductor is joined to the metal or the gold or silver such that high energy electrons exist in the diode. These are termed as the hot carrier or head carrier diode, and so this diode is called the hot carrier. Why it is called a hot carrier? Because N-type semiconductor is joined to the metal, that will be the gold or silver, such that the high energy electron exist in the diode. So these terms as a hot carrier, large number of the electrons, high energy level. Next is a Schottky diode. It doesn't have the minority carriers and no depletion region exists, rather a metal semiconductor junction exists. When this diode is forward biased, it acts conductor, but the charge have high energy level, which is helpful in the fast switching, especially in the digital circuits. So most of the time Schottky diodes are used in the microwave applications. The Schottky diode has a lower forward voltage which drops than ordinary silicon PN junction diode. At low current, the voltage drops maybe between the 0.15 to 0.4 volt, as opposed to the 0.6 volt to the as in the silicon diode. Means low current can be flow. When we use the low current flow, then we use the Schottky diode. To attain this performance, they are designed in a different way to compare with the normal diode, having the metal to the semiconductor contact. Here we use the semiconductor contact in this type of diode used, and they are mostly extensively used in the rectifier application, clamping diode and RF application. This is a symbol of the Schottky diode. This is the diode and this is the original diode which are used. Next is the tunnel diode. The PN region in these diodes are heavily doped such that the existence of depletion is very narrow. It means it works in the forward biasing. It exhibits the negative resistance region which can be used as an oscillators. Then the microwave amplifiers, where when the diode is forward biased, firstly since the depletion region is narrow and the electrons tunnel through it and the current increases rapidly with the small change in the voltage. So it is very simple because it is working in the forward bias, so depletion layer is width of depletion layer is narrow. When the voltage is further increases due to the excess of electron in the junction, the width of depletion region start to increase, causing the blockage of the forward current, whereas the negative resistance region formed. When the forward bias is further increases, it acts as a normal diode. So this is a tunnel diode. The symbol is like this. And next is the pin diode. Pin diode, you can see on the diagram that there is a PNN and in between that there is a intrinsic semiconductor. In this diode, a PN region are separated by an intrinsic semiconductor. You see in the diagram PNN and here is a intrinsic semiconductor. When the diode is reverse biased, it acts as a constant value capacitor. So in the forward bias condition, it acts as a variable resistance which is controlled by the current. So it is used in the microwave application and which are to be controlled by the DC voltage. Now what are the application of the diode? As we know, the different type of the diodes are here and they are used in the different circuits also. So on the basis of the material we use, we can construct these type of diodes. Now what are the basic application of the diode and how they are used? They are used almost in all the electronic circuits. So some of the application we will discuss here, that is used in the regulated power supply. Particularly, it is impossible to generate the DC voltage and only type of the source available is the AC voltage. So it converts the AC into DC. Since the diodes are unidirectional devices, it can use to convert the AC voltage to the pulsating DC, and with the further filtering sections, an approximate DC voltage can be obtained by using this. For this you can use the capacitor and inductors, and then it converts the AC into the DC voltage. Now next is the tuner circuit. In the communication system, at the receiver, and since the antenna receives all the radio frequencies available in the space, there is a need to select a desired frequency. So in the tuner circuit, it is used to select the desired frequency. So tuner circuits are used which are nothing but the circuit with variable capacitors and the inductors. In this case, a vector variable diodes can be used. In the television, traffic lights and display boards, we use the diodes. As we know, in order to display the images on the TV or the display boards, LED are used. Since LED consumes very less power, it is extensively used in the lighting systems like LED bulbs. Other applications is used in the voltage regulators. As Zener diode has a very low breakdown voltage, it can be used as a voltage regulator when reversed biased. Detectors in communication system, a well-known detector which uses diode in an envelope detector, which is used to detect the peaks of the modulated system. So these are the basic application of the diode. Some common application of the diode, that are the, before taking look the various application of the diode, let us quickly take the peak of at a small list of the common application of the diode, and that we will discuss later how it is used in the rectifier, clipper circuits and clamping circuits, reverse current protection circuits, in logic gates. You all know about the logic gates, and I think you are in the series of the logic gates where you are learning about the multiplexers like registers, and these logic gates are used here. Then in the logic gates, OR gates, AND gates, whenever we discuss any gates, then we use these diodes. So what type of diodes? By using this diode we can convert the OR gate into the AND gate, and like that, and that you can learn more about it in the logic gates lecture. In the voltage multiplier, we use the same in the logic gate. In the voltage multiplier, we use the diode. There are the many more application. Now understand each of the application of these diode in detail in the further lecture. So here we see the rectification, we use the diode. You see here in the diagram that this is a half wave rectification where we use the diode. This is the full wave rectification. So in this manner you are seeing that the 4 diodes are attached here. Then here the 1 diode which is used in the half wave rectification. Basic application of the diode. Any circuit without diode is nothing. So in most of the circuit we use, and the diodes are made based upon the material we use, like LED, like pin diode, like variable diode, and laser diode, where we use the lasing material in preparing the laser diode, which produce the light energy. Now this is the full rectifier, where we use the number of diodes, and it converts the AC signal into DC signal, and it made up of the 4 diodes in the specific configuration, which is known as the bridge rectifier. Diodes in the clipping circuits. Clipping circuits are used in the FM transmitters, where noise peaks are limited to a particular value so that the excess peaks are removed from them. The clipper circuit is used to put off the voltage beyond the preset value without disturbing the remaining part of the input waveform. So based on the diode configuration in the circuit, these clippers are divided into 2 types. First is a series clipper, and second is the shunt clipper. So they are again classified into different types, like as a clipper. And you see, the clipper is a circuit made of the diodes that is used to shape the signal waveform by clipping or cutting either a portion of the positive half or the negative, both the halves of the signal, and it is used to limiting the voltage at the predetermined point. Similarly here in the clamping, a clamping is a circuit that adds a positive or the negative DC value shift to the signal without distorting its shape. The peak to peak value of the signal remains the same. The clamper is made up of the diode with the capacitor, you see here. And this is a logic circuit, where logic gates, where we use the diodes. You can see on the diagram. Thank you very much.